Hello everybody and welcome. My name is Mihir Patel. I'm a chemical engineer by profession as well as a project management professional PMP and a TUE suit certified functional safety professional. With the grace of God, I had the good fortune of writing a composite chemical engineering book titled Mihir's Handbook of Chemical Process Engineering. Today we will be discussing a specific chapter, chapter number 9, which is on separators in the book. Now this particular chapter is dealing with two-phase and three-phase separation, which is very much required in many industries. For example, at the top of a column you have a reflux drum. So that reflux drum is a two-phase separator. So it separates the vapor, which mostly will be inerts, from the main chemical which you are distilling. For example, you have a small plant where you have a amine regeneration unit, ARU, which is called. So that has a feed drum where, for example, three-phase separation occurs. So you have gas separating out in that drum, as well as you have a little bit of hydrocarbons and the main amine liquid. So that is a three-phase separator. Each and every separator is designed as required for that particular process. Let us talk about two-phase separators. Now, when you have two-phase separators, the gas and the liquid are being separated. The equation which applies to this separation is called Souders-Brown equation. For three-phase separators, Souders-Brown separates out the gas from the liquid, whereas for three-phase separators, you have liquid-liquid separation also. Let us say hydrocarbons separating from amine, for example, or you have crude oil and water separation out. So in the liquid-liquid separation, you have different laws depending on the Reynolds number. So you have Stokes law, you have intermediate law, and you have Newton's law. Stokes law where NRE is less than 1, intermediate law for NRE from 1 to 1000, and Newton's law for NRE greater than 1000. So this is how the two-phase, three-phase separators are designed. Now the separator configurations are also many. For example, for the inlet, you have the many inlet devices are there. You can have a half pipe which takes the liquid and the gas towards the inlet dish end. So a change of momentum contributes to the separation. Then you have the gravity separation occurring. You can also have cyclones in the inlet as a distribution. Similar to that, in the outlet you can have, for example, in the outlet gas you can have mist eliminators, which is nothing but a mesh pad. You can have vane pack eliminators, or you can have cyclone eliminators also in the outlet for separation of the entrainment liquid in the gas. Now this is as far as the two-phase and three-phase separators are concerned. In the handbook we have given many examples covering the non-critical separations, critical separations. Some configurational differences are there. Now you can have a vertical separator, you can have a horizontal separator. Vertical separators are always used when the liquid to gas ratios is less than 15% as a thumb rule. So that means the lesser liquid, more gas is there, so you go with the vertical separators. For example, a compressor has a suction KOD where you don't expect too much liquid, so you can go with a vertical separator. Under normal conditions where a lot of liquid is there, you have a horizontal separators. Now there is a certain thing called a surge volume. Suppose you have a small plant where the amine regeneration unit example I had given you. There it is not much relevant to have a surge volume, but suppose your feed drum is collecting the feeds from many oil wells. So here you have pipelines running over many kilometers and there is a chance of surge occurring. So it is very important that in such a vessel you also have a surge volume as part of the design. So this is as far as the design is concerned. Now we will also discuss the flare KOD. Now flare KOD is designed by another method which is called drag coefficient method. It is a safety issue. You cannot give a mesh at the outlet of the gas leaving the flare KOD, because in case that gets stroked, the whole safety is compromised of the relief system. So the flare KODs are designed with the drag coefficient method. Now I have given templates, calculation templates for each and every of these two-phase, three-phase separators, as well as the bucket and wear type separators, as well as the drag coefficient type design in the handbook. Also the data sheets are given in the handbook. Please do visit the website www.chemicalprocessengineering.com for Mihir's handbook, which will aid the process engineer in doing a very practical design of process engineering. Please also like and subscribe to the channel. Thank you.